Hi there. This video is an overview of the project found on Octi's website for the TIJ1O course with a connection to computer technology. With the way electric cars are becoming more of the norm, the industry of transportation will be in need of various jobs within the industry. The Ontario Vehicle Innovation Network, OVIN, is seeking to fill these areas with Ontarians who are highly skilled to be able to help our future in the automotive sector. By being able to introduce a connection to the automotive industry and computer technology, the hope is that we as teachers might be able to open doors to allow students to see that they have more opportunities in their future. Using the microbit, we will allow students to see how the simple parts of a car are created and allow them the creativity to be able to engineer perhaps new ways of helping the automotive industry. This will allow also a connection to the UN's global goals of sustainable development goals. Students will connect their projects to either number 9, which is industry, innovation, and infrastructure, or number 11, sustainable cities and communities. If you want, you can take a look at some other ones, but these are the ones that I selected. At the core, the microbit will teach students the intricacies of basic features of an electric dashboard inside an automobile, and perhaps gain an awareness of the computer and electrical engineers that are needed in the automotive and mobility sectors. So my first slide deck outlines the basics of this project, and it's a project-based learning unit. But don't worry, if you've never coded before, you'll be fine. Most of the code is copied right from where students will take a look at it and then they will copy it. If you have never used a breadboard before, my suggestion is that you practice with those resistors. They always seem to be tricky. Sometimes I have to lay my finger on top of the resistor to make it work, and then it will just magically light up. I've done this in my class to test it out and make changes. So this unit should work very well for you. I have made some changes and you might need to do that as well to fit your class. But I've tried to bring you the very basics so that your open level class can adjust to these lessons. If you're looking for modifications for your students with IEP, please reach out to me. I have them. So let's start with the end in mind. The goal of the lessons are to show students how to go through the engineering design process. And as they look at how to create something connected to not only the auto industry, but they also want to connect them to the global goals of industry innovation and sustainable cities. If you are able to question the students on how the auto industry is responding to the issues rather than just a connection, you'll get better results. So that responding, what are they already doing? Because essentially we're copying what we already see. It's very rare that we're actually going to be innovative with the microbit, but it's the idea that they learn the basics of how these started out, and then we can grow from there. This would allow them to show how the automotive industry is responding to the innovations of global goals number 9, because now everyone gets to turn on a light, let's say inside their car, and not just high-end vehicles. Or they could create an alarm with a servo motor, and the arm of the servo motor could move as if it's the windshield wiper. So let's say it moves 150 times, and this would trigger an alarm that would indicate to the driver as a warning that their windshield wiper is going to be needed to be replaced, thus creating sustainability in the vehicle rather than perhaps an accident if the wipers weren't changed in time. A little bit of a stretch, but you get my idea. So that would be goal 11. One activity I do that's optional is I ask 3 of my colleagues who have like higher end vehicles, and I make sure to include an electric car in there. I get them to park at the back of the parking lot, and they're willing to give me their keys to their car, and we go out to the parking lot and we take a look inside the vehicles. Students aren't allowed inside them, and I don't start them at all. We look at all the bells and whistles of the vehicles and they come with, and what is different compared to maybe what they have at their house. Some of them have really high-end vehicles, so it's kind of neat to see like somebody had a Ferrari, and then they come to my vehicle, which is the typical soccer mom vehicle. And we look into my vehicle and we see what is standard across all those vehicles. And what we also do is we take a look at what is seen as a luxury item. So for the electric vehicle, when you go right in, there's not much you can see. So we did take a look at some videos of what's inside an electric vehicle so that we could kind of take a look. I assume everyone has been using a microbit before. Kids are coming in with it very knowledgeable already, so I don't really have them do too much with the microbit. And I keep in mind as well for as you go through this, my days are 75-minute periods. So when it says one day, it's 75 minutes. So you'll just have to adjust that as you need to. And then one of the things that helped me the most was showing students how the breadboard works. So I've included it here in this video, but you can definitely find it elsewhere. But the idea is that if you can show them how it works across the holes and the lines, it really helps. They all think that each one is its own individual and not connected. So that definitely helps them understand how the electricity runs through. So I start off doing some of the activities as a whole group. So back to the slide deck, make sure that everyone knows what they're doing with the breadboard, and then we get more comfortable and I allow certain students to move on without doing what we're doing as the whole class. I just make sure that they show me what they've done or they take a picture of what they've done so that they can catalog. You could create a checklist for all the activities if you wanted to and have this, and then sign off on all the activities. I don't really give marks for anyone who's finished these activities. You can if you'd like. But the idea is that they're learning the process. They're learning by doing. So day 3, after we do the photocell, RGB light, and self-locking switch, we leave the servo for when I actually have like 10-15 minutes at the end. So it may not be day 3. It depends how quickly you can get through the other ones. Day 4, I put more challenging ones in the slide deck. And I said that they could pick one, and then just make sure that your neighbor's not doing the same one. And then this allows them to see what other people are doing or to help other people out. I will say that there is some frustration in if the light doesn't work or the button won't work. And I often ask for another set of eyes on the breadboard if I can't figure it out. Some of the troubleshooting ideas I have, if the above isn't an option, I've swapped out a part that doesn't seem to be working with a spare, or once someone does have a particular one working, have the student walk over to the one that isn't and compare. Lastly, if a student says, for example, the motor isn't working, but then somebody else's motor is working, the fan's moving, swap out the motor and see if it works in their setup. And then if it does, then you know that you might have a dead motor. They're not that expensive, so you can replace them. Now, so after you get through all the basics of that, you have the main project. And students will go through the engineering design process and fill in parts on the slide deck for marks. This can be 1 or 2 hours or classes. I really spend time here and sit down with each student to go over this particular part individually to see how they connect the global goals to what they've chosen. If the global goals seem to be a stretch for your students, then my suggestion is you drop them for now and continue the project connected to auto and have them recreate what they see in that car. And then when they're done, you can sit down with them and help them make those connections about how they can create, how what they've created can be seen as an innovation for what cars used to be. Remember that their background, they might not know what rolling up a window is, or having to manually lock a button or a door, or you know put in a key to open a door in a car. So that's something that they might not have that experience. So you can show that, at least you can research it if you're young enough and don't have that experience either. In Showcase, That's our next step in showcase. Students have to make a video for me in class. Now I use ScreenPal or Screencastify, and I will say that I may have a limit of 7 minutes, especially if you have a full class. It's a lot to listen to, but it's good to keep them so that they can keep it down. In my class, we do go around the whole class and everyone states what they're doing and how it's connected to the global goals. I also ask them what they're most proud of. And that's when others get to hear the struggle is real. Because everyone faces a challenge and everyone faces different challenges, but they're proud when they overcome them. And they're able to tell others how they overcame them, and it might help somebody else. If you've never coded, this is a great place to start because almost all of the copying is done for the code, and combining some of the other options together is maybe the more advanced programming logic. So give it a go. It's not scary. You can learn with your students. It's okay. And I think you'll have a lot of fun. I will say that nothing is perfect, but this project is a lot of fun, and the students really enjoy making parts of this project. And I think you'll enjoy marking it. If you need any more resources or want to reach out, my name is Melissa Oliver, and I can be found at molliver@smcdsb.on.ca. Thanks. See you.